Here. Here, come over here. Fabulous. Okay. We're probably just gonna have to squeeze like a little bit. I don't think we're on. I think it's okay. Okay. Um, yeah.
And guys, when you take turns to talk, make sure you speak loudly because you won't have a lavalier. So Home's the only one, and they won't be able to hear.
Hi guys, welcome to the mock exam #1 office hours for Peer Genius. We just wanted to thank you guys before for signing up to do the mock exam, and now we're going over all the solutions to the mock exam today. Before we do that, I did want to do a quick introduction of the Peer Genius team. This is Mia. My name is Hannah Staus. Jason, we're the co-founders of Peer Genius. And today we'll be going over the solutions to the AMC 10 mock exam #1. Soham right here is going to be the lead instructor for this live stream. And over here are all of our gurus for today. One last thing. If you do... Okay, if you do have a separate question, or if you have a question and need one-on-one help, make sure you open up another tab on your laptop. Go to peergenius.io and click to have a one-on-one. If you click to have a one-on-one help, and you will be transferred to a text channel with one of our gurus, in which you will be able to receive one-on-one help on any questions that you have. Okay, we're going to get started now. Thank you.
Hopefully everyone can hear me. Okay, so I'm just going to be going through the 1 through 25. I'll just be going through solutions. So just like Hannah said, if you have any questions while I'm doing it or once I'm finished, just request a guru, and one of the 4 gurus will get to you. And then, yeah, hopefully they'll be able to answer your question. Okay, so let me just start with number 1. So, also, you guys can pull up your AMC 10, the mocks PDFs that were sent through the email, or yeah, just pull them up so you guys can go with me. Okay, so if Bob has 2 identical yellow hats and 4 identical blue hats, how many ways can he choose a hat for himself and a hat for his friend Carl? Okay, so so he has 2 identical blue hats. four identical blue hats and 2 identical yellow hats. And then now, how many ways can he choose a hat for himself and his friend Carl? So there's only, for himself, he can choose either a blue hat or a yellow hat since they're all identical. So he has 2 choices for himself. And then he also has 2 choices for his friend Carl. Okay, so just 2 times 2, 4. So the answer should be A. Okay. Okay. So hopefully everyone's okay with that. Okay, let's move on to number 2 then. So a bag has a mix of yellow and blue balls. Andy picks 3 balls from the bag without replacement. The probability that all the 3 balls are yellow is 2 over 33. What is the possible minimum number of blue balls in the bag initially? Okay, so just for AMC techniques or like tips in general, it's a multiple choice exam. So you can just go through each of the answer choices if you don't really have a clue on how to start, and then you should be able to get an answer if it's a question like this. Okay, but so some things to notice here is that it's without replacement. So the probability that all 3 balls are yellow is 2 over 33. Okay, so that means. So it's like b over b plus y times, yellow balls? Okay. Y over b plus y times y minus 1. Okay, so you need 3 consecutive numbers to multiply to 2 times some number. And you also need 3 consecutive numbers to multiply to 33 times some number. So let's see. So let's just list out 33, 66, 99, 132. So wait, I forgot to do this, bro. Okay. Yeah. Wait. Yeah. Okay, we're gonna actually bring up Min here.
So the denominator is 33, and like Soham said, the denominators, we're multiplying 3 fractions, and since there's no replacement, these should be 3 consecutive numbers. When you prime factorize 33, we get 3 times 11, and we want minimum number of blue marbles. So we can have one of the 3 denominators be 11. That gives 3 cases where the denominator is 11, 10, and 9, or 12, 11, and 10, and 13, 12, and 11. And when we look at each case, let's look at the first case. That means the denominator is going to be 11 times 10 times 9, and the numerator is still going to be y times y minus 1 times y minus 2, but the denominator here is 11 times 2 times 5 times 3 times 3, and since this fraction and this fraction is the same thing, it's just a reduced form, that means we need to multiply 2 times 5 times 3 on the numerator, because it's this is already there, and these 3 are multiplied. And when we rearrange this into this form, we know that y is 5, 4, and 3. So, well, the first case worked, so we don't really need to check these two cases. So y is the yellow marble. So that means y is 5, and b plus y is 11, so b should be 6, which is D.
Yeah. Thanks, man. Okay. So I'll just leave this up here for like 5 seconds if you guys want to just look at it a little bit more. Yeah, so if you guys have any questions on this, just ask the gurus. You guys can request them through the Pew Genius chat window. So, yeah. Okay, so I'm going to erase it now. Let's move on to number 3. Okay. Number 3. P of x is a cubic polynomial with real coefficients which satisfies P of 0 equals negative 12, P of 1 equals 0, P of 2 equals 0, P of 3 equals 0. What is P of 4 equal to? So it says P of x is a cubic polynomial. This means that degree of P of x equals 3. Okay. It also gives you the 3 zeros, which means the 3 zeros are at 1, 2, and 3. So which means P of x can be written as a times x minus 1 times x minus 2 times x minus 3. So yeah, so pretty much if you plug in 1, 2, or 3 into this polynomial, it's going to give you 0. And it also gives you that P of 0 equals negative 12. So if you plug it P of 0 into here, it also equals a times negative 1 times negative 2 times negative 3. Okay, so which means negative 12 equals a times negative 6. And a equals 2 then. So now you get the cubic polynomial as P of x equals 2 times x minus 1 times x minus 2 times x minus 3. So once you plug in 4 into here, you get P of 4 equals 2 times 3 times 2 times 1, which is 12. So your answer should be E. Yep. Okay. So I'll just leave this up for 5 seconds again, if you guys want to look at it. And just, yeah, as always, make sure to ask questions if you have any. Yeah. Okay. Okay, we're going to move on to number 4 now. Okay, so what is the area in the region absolute value of x minus 10 plus absolute value of y minus 5 is less than or equal to 100? So for most of these like absolute value questions, you're either going to be checking both the positive and the negative case, or you're going to be checking for extreme cases. So pretty much you're going to be drawing a graph. And I'm just going to be plotting points here to see like how the figure would look. So when y is 0, the maximum value of x would be 110. So this is not going to be to scale, but yeah. Okay. So maximum value when x is negative is going to be negative 90, 0. And when x is 0, the negative value is going to be 0, negative 95. And when x is 0, the positive y value is going to be 105, comma 0. Okay, my bad. Here it should be 110, comma 5, because you want y minus 5 to equal 0. And here it should be negative 90, comma 5. Okay. And here it should be 105, comma 10, and oops, 10, comma 105, and 10, comma negative 95. Okay. So yeah. So these are all linear, so they're going to be straight lines. And now, as you can see, this is a quadrilateral. Both of these diagonals are parallel to the axes, which means they're perpendicular, which means you can, the area of this sort of quadrilateral is just going to be the two diagonals times each other and then divided by 2. So the length of this diagonal is going to be 200 times 200 divided by 2, which is 20,000. So yeah, so the answer should be D then. Yeah. Okay. Yeah, I'll just leave this up for 5 seconds again. Yeah, so if you have questions again, just make sure to ask. Our gurus are just here, ready to help. Okay, so moving on to number 5. Okay, number 5. The AKG farm raises only pigs and chickens. Chickens have 2 feet and pigs have 4. If there are 216 total feet and 12 more pigs than chickens, how many pigs are there? Okay, so this is just, it seems like it should just be a basic 2-equation system. So chickens, let's say you have C chickens and P pigs. And P pigs. So this means you have 2C legs, or 2C feet from chickens and 4P feet from pigs. So this means that 2C plus 4P should equal 216. And you also have the equation that there are 12 more pigs than chickens. So which means C plus 12 equals P. So now you can just substitute in P. So you get 2C plus 4 times C plus 12 equals 216. Or, yeah, sure. So actually, it would probably be better to just sub in C, actually. C is P minus 12 since you're trying to solve for pigs. But it's fine. It's just like a simple like subtraction. So here it would be 6C plus 48 equals 216, and 6C equals 168. So now C equals 28 then, and I'll move here actually. P equals C plus 12, so P equals 28 plus 12, and P equals 40. Okay, so P should be 40 then. which means the answer is D. Okay. Also, what I did here, I didn't really like show my work too much, which is something I don't recommend when you're taking the AMC. It's really easy to make like silly mistakes. So it would probably be better to just do like actually go through like 216 minus 48, like actually go through it. So I'll just go through it just to make sure I didn't make a mistake. And then do 168 divided by 6, which is 28. Yeah. So yeah, always make sure to do like the simple addition, because even though it's simple, it's easy to make a mistake on it. So yeah, I'll just leave it up again for 5 seconds. Okay. So now we're gonna have Kevin come up here to do number 6. Also, make sure to ask questions. This was number 5. So yeah, just ask questions if you have them. So.
Okay, so for number 6, it says when the number in the list 3, 7, 11, and x are arranged in increasing order, they form an arithmetic sequence. What is the sum of all possible values of x? So basically, there are two cases for this. The first case is that x is bigger than 11. And the second case is that x is less than 3. This is because like if x won't be in between any of the two numbers, because if we do that, there won't be a common difference. So let's just set up the two cases. So it would be 3, 7, 11, and x, right? And the second case is x, 3, 7, and 11. We see that the common difference is 4, so because this is plus 4, and this is also plus 4, so for this it should also be plus.
Also, yeah.
Oh, plus, yeah. Okay, so this would be 15. And for this one, it will be basically minus 4, and also minus 4. And this would be negative 1. So if we add these two together, it would be negative 1 plus 15 equals 14. And that should give you C.
Yep. So now we're going to have Ian coming up to do number 7. Wait, let's just leave it up there for 5 seconds.
Right.
Make sure to ask questions if you have any.
All right, perfect. So number 7 is asking how many positive digits. Let. Okay, just leave it. Sorry. All right. So question 7 is asking how many positive integers less than 1,000 are divisible by 6 and 15, but not 20. And the way you figure this out is it's best to write them out as factors. The factors of 6 are 2 and 3. The factors of 15 are 3 and 5. And the factors of 20 are 2, 2, and 5. Now, the least common multiple of 6 and 15 is 30. So you can say if a number is divisible by 30, it's divisible by 6 and 15. Now, how many numbers in 1,000 are divisible by 30? The answer to that is 33, because 33 times 30 is 990, which is the largest factor divisible by 30 that's not greater than 1,000. Now what you can do is so you've got 33 factors right here, and you're trying to figure out how many are divisible by 20. And what you can say is your first factor is 33, which is not divisible by 20. I mean, not 33, 30, which is not divisible by 20. But your next factor is 60, which is divisible by 20. Your third factor is 90, which isn't, but your fourth factor is 120. There's a pattern here where it goes divisible, non-divisible, divisible, non-divisible. And what you can say from there is you extrapolate and say half of the factors are going to be divisible by 20, and half aren't. So you know at least 16 of them. But then you've got your final factor, 990. This is the last case because you've got a divisible value, a non-divisible value, then you've got a divisible value, then you've got 990, which is not divisible. So this final one is going to be non-divisible. So you have 17 numbers that are divisible by 30, but not by 20, which is your answer. I believe it is
D.
D.
So also, this is also a pretty common case of pi, which is principle of inclusion and exclusion. So some theorems that you should know are pi. So I'll just write it down. Pi principle of inclusion exclusion. Okay, so that's just a theorem that you should know. Just go back, like after the session, if you do have questions. So make sure to ask questions on pi if you have them right now. It's also just some theorem that you should look up and just something that you should know before the AMCs come around. So you could also solve this with pi. And now we're going to go on to Joey.
Joey with problem 8. Should I erase?
Yeah.
Problem 8 is integers x, y, and z satisfy x plus y plus z equals 10. X plus y plus z equals 10. And x larger than or equal to 0. But then we have a curveball. Y larger than or equal to -1. And z larger than or equal to -1. Now the question is, how many x, y, and z are there? Now, I know that the differing inequalities for x, y, and z might present a curveball, and the typical reaction to that curveball is to attack it straight on, probably with brute force. But a clever way, and one that the AMS recommends, is creative thinking, wishful thinking. What if, instead of that, what if we had the really convenient case of x greater than or equal to -1? Now, because x, y, and z are symmetric, all of this is really convenient. Thinking about that, we don't know yet how to count all of these. So we biject this to a new case where x plus y plus z equals 13, and x larger than or equal to 0, y larger than or equal to 0, and z larger than or equal to 0. Now to count this case, it becomes really easy. Just use the principle of stars and bars.
Actually, I think x should be greater than or equal to 0, right, Joey? I think the starting condition is x is greater than or equal to 0.
I know. This is a modified condition. Okay. Completely modified condition, i.e. wishful thinking. For stars and bars, to solve this, we use like 13 stars here, 13 stars, and then because we want to select for 3 terms, all of which are greater than equal to 0, we can do like this, 2 bars. How many do we have in the modified case? 13 choose 2, or 15 choose 2. 15 choose 2, or 105. Now you might be thinking, how does this relate to the janky condition? How does it relate? Basically, this condition equals the x greater than or equal to 0 condition plus the x equals -1 condition. So janky equals 105 minus the x equals -1 condition. X equals -1 has y plus z equals 11. Because y plus z equals 11, we have this condition has 14 values. This condition has 14 values. So janky equals 105 minus 14 equals 91.
So I'll be. So this was a clever way to go over it. So there's also another way. So the answer should be 91, which is C. So I'm gonna do another solution. It's like pretty similar to this, but it's a little bit quicker. So pretty much, I just kept. This was greater than or equal to 0, and it's pretty much what Joey did, but it doesn't have like the extra subtraction part. So. Okay, this is called, so what he used was called stars and bars. That's what I'm also going to be using. So here, if you just add 1 to the y condition and add 1 to the z condition, you get y is greater than or equal to 0 and z is greater than or equal to 0. Which means x plus y plus z now equals 12. Also, so now you have x plus y plus z equals 12, and your three conditions is x is greater than or equal to 0, y is greater than or equal to 0, and z is greater than or equal to 0. This is a classic example of stars and bars. So now you just have 12 objects, and you have to divide it into 3 parts. And to divide something into 3 parts, you have to use 2 bars. So 1 bar divides it into 2 parts, and 2 bar divides it into 3 parts. So now you just have, now you have 14 things, or 14 spaces, and you have to put in 2 bars. So 14 choose 2 should be 91. So yeah, so we come out to the same answer, which is 91, which is C. Sure? Yeah, C. So yeah, I'll just leave this up for 5 more seconds. Make sure to ask questions, and now we're going back to Ian. Yeah. So now we're moving on to number 9 with Ian. Okay.
So problem 9 is saying Bill rolls a fair 6-sided die once and gets n. So that's a number from 1 to 6. Then he flips n coins. What is the probability an even number of them turn up heads? The way I solve this is with different cases. What happens if he flips 1, 2, 3, 4, 5, or 6 coins? If he flips 1 coin, there's only one option, heads or tails. If he gets tails, that's 0 heads, an even number. If he gets heads, that's an odd number. So there's a 1/2 probability of him getting an odd number of heads. 2, he gets heads. You flip 2 coins, and you can get heads, heads, tails, tails, heads, tails, or tails, heads. There's 2 situations that satisfy an even number. So again, the probability is 1/2. For 3 coins, you can get heads, 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 tails, 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 heads, 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 tails. And what you do is you write out all these different cases. Tails, heads, tails, heads, heads. Oh, okay. All right. Sorry. So you get a bunch of different cases, and what you end up getting is you have tails, 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 and you have 3 different cases for 2 heads: heads, heads, tails, heads, tails, heads, or tails, heads, heads. So this is 4 different cases out of the potential 8. So you get 4 over 8, or 1/2. There's a pattern here, isn't there? If you keep going through all the different sets, you're going to get a probability of 1/2 for each one, and that means that that your answer is going to be E, or a 1/2 probability for everything.
So yeah, the answer should be E then. Yeah, so again, just make sure to ask questions if you have any. Yeah, so now we're going to be going to Min with number 10.
So for number 10, this time we are rolling a dice twice. So we're rolling a dice twice, and we're trying to find the case where the sum of the numbers that are rolled are less than 6. Well, you can't get 1 out of it because the least case, the least sum is 1 plus 1, which is 2. So we only need to consider 4 cases, where the sum is 2, 3,
Oh, you use this one.
where it's 2, 3, 4, or 5. So to get a sum of 2, there's only one possible case, which is 1 and 1. To get a sum of 3, there's 1 and 2. However, the order matters. So there's the flip version, 2 and 1. That's 2 cases. And for 4, similar principle, 1 and 3, 2 and 2, and 3 and 1. For this case, if you flip it, you get the same one, so we only consider them once. And for 5, 1 and 4, 2 and 3, 3 and 2, and 4 and 1. So there are a total of 10 cases. And since that is the favorable outcome, we're going to put that in the numerator. Now we need to find the total outcome, which is 36, because 6 times 6, each row, there are 6 possible cases, 1 through 6 and 1 through 6. So it's 6 times 6, 36, the total outcome. And when you simplify this, you get 5 over 18, which is D.
Also, so just for die problems in general, like if you want to just like look at the additions, you can like kind of draw like if you like label this 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. I'm not gonna like finish the table, but pretty much like if you like draw this out like that, and then in that direction too, you get like the number of possibilities kind of like triangular. So for 1 plus 1, there's 1, and then there's 2 here, 3 here, 4 here, 5 here, 6 here, and then so it's pretty much like actually it goes up to 5. So it goes 1 plus 2 all the way to 5, and then there's 1, 6, and then back down to 5 all the way down to 1, which is 5 times 6 over 2 plus 6 plus 5 times 6 over 2, which is equal to 36. So that just like shows you like the probability distribution of die rolls pretty much. Okay, so yeah, I'll leave this up again for 5 seconds. Make sure to ask questions to all the gurus. So yeah, we're also going to be taking a quick break. Yeah, so 5-minute break. Yeah, just make sure to tune in after 5 minutes. We'll be right back. Thank you. what is the minimum possible sum of the reciprocals of the two numbers? Okay, so it says the product of two real numbers is 9. So let's just say the two numbers are x and y. So x times y equals 9. And they're asking for the minimum possible sum of the reciprocals. So that means they're asking for 1 over x plus 1 over y is 1. So you can write 1 over x plus 1 over y as x plus y over xy, just taking it as a common denominator. So by the AMGM inequality, so the AMGM inequality states that the arithmetic mean of any n numbers is greater than or equal to the nth root of the product of those n numbers. So that means in this case, x plus y over 2 is greater than or equal to the square root of xy. So, and we already know what xy is, which is the square root of 9, which is 3. So which means x plus y is greater than or equal to 6. Okay. So, given that we're trying to find the minimum possible sum of the reciprocals of the two numbers, we're going to take the maximum of x plus y. So that means x plus y's maximum is 6. So that means it should be 6 over 9, which is 2 over 3. Yeah, so which means the answer is E. Okay. Also for just general AMC tips, for any inequalities, know what the case is for equality. So here it says greater than or equal to. So it's only going to be equal if all of these, if x and y are equal to each other. So that means x and y must be 3. So as you can see here, like 3 times 3 equals 9, and 3 plus 3 equals 6. So yeah, now we're going to be having Ian coming up to do number 12. I'll leave this up for 5 more seconds. Make sure to ask questions again. Yeah, so our gurus are just ready to help.
All right, perfect. Let me clean this up. All right, so for problem 12, there are an infinite number of solutions to the system of equations 4x plus 6y equals 155, and 3x plus ay equals b, where a and b are real numbers. Let me write that out. 4x plus 6y equals 155, and 3x plus ay equals b. And if there are infinitely many solutions, we can immediately say that these things are the same line. Because that's what the definition of a same line is. They're the set of points that are all equal. What this lets us do is say, okay, the ratio between these lines are 4 to 3. So if we multiply everything in this line by 3 over 4, we should get this line. If you write that out, you get 3x plus 9 over 2y equals 155 over 4. That's 155 times 3 over 4. And this is your answer. And so you have to sum these two values together. And let me just do that. You get 4.5 plus 465 over 4, which is equal to 116.25. And the value you get is 120.5, which is C. What? Oh wait, it's D. Sorry, it's D. You get 120.75.
That's D.
Oh. Well played, Ian. Yeah, so if you do your math right, you should get 120.75, which is B, which is the correct answer.
So Um, yeah, so here it's like this is 116.25, and then you're adding 4.5 to that. So make sure to just write out like your multiplication and division, because it's like really easy to make mistakes. I'm gonna be moving on to number 13 now. Make sure to ask questions if you have any on number 12. Okay. Okay, so number 13. The lengths of the three sides of a triangle are 16, 30, and 34 respectively. Which number is closest to the shortest altitude of the triangle? Okay, so first time I did this problem, I didn't recognize that this is actually a right triangle. So I used Heron's formula to find the area of the triangle, and then I divided by 34. So pretty much to find the shortest altitude, you want to get the largest side of it. So let's say you have your area as A, then you have 34 times the altitude little a over 2 equals A then, right? So versus like where if it was like, let's say it was like 30, then your A would be like bigger. So that means A2 is going to be greater than A1, which means it's, actually, sorry, A2 is going to be greater than A1, so which means A2 would not be the shortest altitude. However, it's a lot easier if you just notice that this is a right triangle. So for the AMCs, know your Pythagorean triples. So this is a multiple of the 8, 15, 17 Pythagorean triple, which in this case is going to be 16, 30, 34. So if I just draw this out, that means this is going to be 16, 30, 34. That means this is going to be a right angle. That means it's a lot easier to find the area. So 16 times 30 over 2 is the area, which is 8 times 30, which is 240. So that means 34, and then that means this is going to be the, this is 90, that's going to be the shortest altitude. So which means 34 times A1 over 2 equals 240, and then A1 is going to be 480 over 34, which is 240 over 17. So it says which number is closest to the shortest altitude. So now I'm just gonna like move up here. So 240 divided by 17. I'm just gonna go through it. Okay, so that means 14 is the closest, which means the answer should be B. Okay, now we're gonna have Joey come up to do number 14.
Number 14 is how many factors does the integer least possible integer with 100 digits have? Now, our first question is, because we want to tackle this directly, what is the least possible integer with 100 digits? Now we know that the least possible integer with 2 digits is 1, 0. Is the least possible with 2. The least possible with 3 is 100. The least possible with 4 is 1,000. Now, the obvious thing that should pop out at you is that the least possibles are just 10 to the 1, 10 to the 2, 10 to the 3. So the least possible one with n digits is 10 to the n minus 1. Based on this, we can logically conclude the least possible with 100 digits is 10 to the 99. Now, how many factors does 10 to the 99 have? We prime factorize it into 299, 599. Now, it is a trivial law that the amount of factors that you have is basically related to the prime factorization by this plus 1 times this plus 1. So, I'm sorry. So the prime factorization of this then become the amount of factors of 1099 equals 100 times 100 equals 10,000. Now, I know you want to know where I'm getting this. Where I'm getting this is basically if you want to have all possible number of factors, then you can choose everything here from 2 to the 0 up to 2 to the 99. There are 5 to the 0 up to 5 to the 99. And if you multiply those permutations together, you get.
What numbers?
10,000.
So the answer choice should be letter D. So now we're gonna have Kevin come up to do number 15. Okay. So let's just leave it up there for. So that was number 14. So yeah, that should have been number 14. And then now we're gonna be going to number 15. Okay. So just.
Okay, so number 14. How many factors does the least? Wait, no, sorry. Number 15. What is the least integer with exactly 12 divisors? So basically, for this problem, we have to use prime factorization, and for this, like we have to know, for example, if 2/3 times 3/4 or like 3/5, there will be 4 times 6 equals 24 factors, and this is because we add 1 here is 4, and then this one we add 1 is 6, and then we get 24 factors for this. So for this problem we have to know this, and so for this it says what's the least integer with exactly 12 divisors. So 12 can be factored as 3 times 4, 2 times 6, and also 2 times 2 times 3. And because it's prime factorization, we use 2, 3, 5, 7. So let's just say, for example, let's just use the first case, 3 times 4. So basically we put 2 squared times 3/3. So this is a possible choice. And this is 4 times 27. So this is 27 times 4, 108. So, and then another choice is 2 times 6. So we can do 2 times 3 to the 5th. And this obviously would be too bigger than this one, so let's just cancel this. And then for 2 times 3, you do 2 to the first times 3 to the first times 5 to the 5 squared. That would be, oh no.
2 squared times 3 times 5.
Yeah, 2 squared times 3 times 5, and that would be 60. And this would be our answer, which is B.
Yeah. So for just going through all the cases, you should be able to get it. So here, like, actually, I think for this one, the smallest would actually be 2 to the 5th, or 2 to the 4, or yeah, 2 to the 5th times 2. So which is 96, but it's still bigger than 60. Yeah. But yeah, you're trying to get the largest power on the smallest prime factor. So yeah, which is what Kevin did, and you got 60 as the answer then. So that was number 15, and then now we're gonna have Ian come up to do number 16.
All right, awesome. So number 16 is asking you have to have a certain, you're given a certain number of guesses where you're asking is the number greater than or less than 1,000. So you have a number from, I believe it's a positive integer, so you have a number from 1 to 1,000, and you're trying to figure out the least number of guesses to figure out what that number is. If you can only ask, is the number larger than, or is it smaller than a certain number? What this basically is you have you're looking at it in terms of powers of 2, because each question you ask brings you, it divides the number of possibilities by 2, because the number can either be larger than or smaller than the number you guess. So you're trying to figure out how many 2's you need to divide 1,000 by, your total set, to get a number that's smaller than 1, which basically means you found the number. And if we look at our powers of 2, we have 2 to the 1, which is 2, 2 to the 2, which is 4, 2 to the 4, which is 16, and you keep going down your list until you reach 2 to the 10, which is 1024. This is something you should know. 10, it's fairly easy to remember. But what this tells you is 1024 is greater than 1,000. So that means we have to have 10 different options or 10 guesses to get the number every single time, which means our answer is B. All right, now I'm going to turn the stage over back to Soham for question 17. So actually, okay.
Okay, so number 17 is a typical geometry problem that involves the area of triangle. So we know the 3 side lengths, which are 5, 6, and 9. And before we actually solve the problem, we're just going to kind of review the formulas for finding the area of triangle. So there's 1/2 times base times height. And there's also r times s, where r is the in radius and s is the semi-perimeter. I should take the and there's also something called Heron's formula, which is where same S is the semi-perimeter and A, B, C are the 3 side lengths. For this problem, so and the last way is A, B, C over 4R, big R, where this is the circumradius. However, for this particular problem, we're only going to use this formula and this formula. So the 3 side lengths are 5, 6, and 9, and we can find the area of triangle by using the Heron's formula. So S is semi-perimeter, so 5 plus 6 plus 9 over 2, which is 10. Yep, and now we just use the formula. So area equals 10 times 10 minus 5 is 5, 10 minus 6 is 4, 10 minus 9 is 1. So it's this, which gets simplified into 10 rad 2. And now that we know the area of the triangle, which is 10 rad 2, we can use another formula, the in radius times the semi-perimeter. since this is the same triangle, we can let this equals 10 rad 2. So, and we already got the semi-perimeter, which is 10. So 10r is 10 rad 2. So r is rad 2. So in radius is rad 2, which was rad 2 is b. B is the correct answer.
Okay. Now we're going to be doing number 18. So, how many positive integers? Oh, let's see. For that last problem, there are a lot of important formulas that been went over. So for area, you should like pretty much know a lot of formulas, a lot of different ways to find the area of a triangle, given like side lengths or like circumradius or in radius. So there's Heron's formula. There's area equals in radius times semi-perimeter, and then there's also ABC over 4R, where ABC are the side lengths, and it's like a big R, so it looks like this. So ABC over 4R, where R is the circumradius. I'll just define these, and also equals RS, where R is the in radius. So let's say there's a triangle with A, B, C as the points, and then the side lengths are A, B, and C. So, so the in radius would be defined as the intersection of the angle bisectors. So if you draw a triangle, or I mean a circle, sorry, that is tangent to each of the sides, this would be the in radius. And then the circumradius is the circle around that intersects all 3 points, where this would be the circumradius, and this is the in radius. So the in radius, or in the in center, is the intersection of the angle bisectors, whereas the circumcenter is the intersection of the perpendicular bisectors. So this was just a definition of some of the formulas that Min went over in problem 17 and some of the vocab that he used. Okay. So yeah. Okay, so now let's move on to number 18. Okay, so how many positive integers exist such that the number of factors of n is at least n over 2? Okay, so let's see. So when I looked at this, I wasn't really sure how to go at it straight away. So I just started off with small cases. So let's see, like 2, how many factors does it have? It will have 1 and 2. 1 just has 1. So this has 2, which is, so n over 2 here is equal to 1. And this has 2, which is greater than. So that these are both possibilities. 3 is also 1 and 3. 4, 1, 2, 4. 5 is 1 and 5. So it seems, so all of these work. And then, so 5 doesn't work. So, however, if you just go to 6, you can see that 1, 2, 3, and 6 work, which is 4, which is greater than 3. But for 7, of course, since it's prime, it's not going to work either. Okay. So, also, it says positive integers. So, make sure if like the vocab, it says like, if it says like positive versus like non-negative, they're like, it's, so non-negative means greater than or equal to 0, whereas positive means greater than or equal to 1. But also, so here there's also going to be 8, where it's 1, 2, 4, 8. And it also says at least, which means it's greater than or equal to, which means the equality case here holds. So, okay, so there's also going to be 12. 1, 2, 3, 4, 6, 12. And then, okay, so this was 2 squared times 3. So we're trying to like maximize the number of factors here while minimizing the number. So let's say we have a number that like we would think has a lot of factors, like maybe 2 cubed times 3 squared or something. So this has like a lot more factors than all of these. It has 12 factors. However, the numbers, it gets a lot bigger, where here it's like 8 times 9, which is 72. So 12 is a lot less than 36. So pretty much as you get like larger and larger, let's say like 13, 14, 15, you're just getting bigger. Your number is getting a lot bigger than the number of factors that you're gaining is growing. So pretty much at this point, at around 12 here, it stops. So it should just be 1, 2, 3, 4, 5, 6. So the right answer? Is it? I think. I feel like it's 7. No.
18 says the answer is 70.
7. That means I'm missing a case. 1, 2, 3, 4, 5, 6, 7. Oh, I did not circle 8. Okay.
And
Five.
there's and
Yeah.
14 also
It does not
works.
work. Okay, so
14.
no, it doesn't.
Oh,
Okay,
it's a
so
number.
yeah, so I just forgot to circle a number. So 1, 2, 3, 4, 5, 6, 7. So that means 7 is your number of numbers, which means D should be your answer. Yeah, sorry about that. Yeah, so I'll just leave this up here for 5 more seconds. Make sure to ask questions. Gurus are waiting to answer. So yeah. Okay, so I'll be moving on to number 19 now. Okay. Okay, so number 19. In the Cartesian plane, triangle ABC is drawn so that A is at negative 200, 0, and B is at 143, 0. We also know that AC equals 210 and BC equals 259. What is the x-coordinate of C? Okay, so this is just, so I'm going to draw a graph first. Okay. So it says the point A is at negative 200, 0. So that's A, negative 200, 0, and then B is at 143, 0. And then AC equals 210, and BC equals 259. So let's say like, I'm just going to put C at some random spot. So C, okay, it also says AC is 210 and BC is 259. Okay. So let's see. This length here is 343. Okay. And then now, let's see, let's drop a perpendicular here. So both of those are right angles then. And if I label this as some length x, and then this is 343 minus x, and then this is h. Now we can just write Pythagorean theorem formulas here. So we're going to get, yeah, so I'm going to write 343 minus x squared plus h squared equals 259 squared, and x squared plus h squared equals 210 squared. Okay, so now first instinct might be to kind of like factor this out or like expand it all the way, but there's actually a quicker way. So you see two squares on the right hand side of both of the equations. So it kind of like tells you might want to use difference of squares. So here, if you subtract these equations from each other, you get 343 minus x squared minus x squared equals 259 squared minus 210 squared. Which means by difference of squares, which is just a squared minus b squared equals a plus b times a minus b. So here it's 343 minus x plus x. So 343 minus x plus x times 343 minus x. That equals 259 minus 210 times 259 plus 210. So, okay. So now you have 343 minus 2x times 343 equals 49 times 469. Okay, so now pretty much you can solve for x. 343 minus 2x equals the right hand side divided by 343. So 343 is 7 cubed. This is 7 squared. And you can factor 469 as 7 times 67. Yeah. Okay, so that means you can, and then 343 minus 2x here. Okay, so now you just get 343 minus 2x equals 67, which means 2x equals, I'll just do it on the side. $276, which means x equals 138. So now we're looking at the x coordinate of the point C. So we know that the x coordinate of this point is going to be 143. And that means, and the x coordinate of this is negative 200. So pretty much, if we add, that means this length here is going to be 138. So negative 200 plus 138 is going to be negative 62 then. So which means, so I actually drew C on the wrong side, but it doesn't really matter. So we still got the right answer. So that means the x coordinate of C should be negative 62 comma something, which doesn't really matter. So that means your answer should be negative 62, which is C. Okay, so now we're going to be taking another quick break. So make sure to tune in after 5 minutes. So yeah, take a break. Yeah, we'll come back soon. Thank you.
And back to the studio with your friendly television presenter, Joey Chen, presenting number 20. Basically, number 20 is asking about number of 4-digit integers with the sum of digits equals odd. Now, if you're vainly trying to list them all out, or even follow some procedure, like listing the ones first, 10 digits first, blah blah blah, I mean it'll work. But there's one clean way that will guarantee us very good solutions. Let's have a generic odd number. Let's have a generic number with the sum of the digits being odd. That number is A, B, C, D. Number is A, B, C, D. Now, we tried to find a watertight connection between this number and another even number that'll work for all such odd numbers. Can one odd number be connected to one even number in a way that symmetrically works? Let's consider the number 9999. Now, what do you get when you subtract 9999 from A, B, C, D? 9999 minus A, B, C, D will be something like A prime, B prime, C prime, D prime. Who cares? The important thing is that 9999 is guaranteed to have an even amount. The sum of digits is even. The sum of digits is even here, and because we defined A, B, C, D like a generic variable to have the sum of digits equals odd, what can we conclude about this? We conclude that the ABCD's mirror image also has some odd. Now let's push this a little further. Let's have E, F, G, H. Let's have E, F, G, H with the sum of digits being even. Now applying the magical formula something to 9999 minus something, we get 9999 minus E, F, G, H equals some other number. The important thing is, again, because 9999 is both a keystone number and a sum even, and this is sum even, we get this is also sum even. We get this is also sum even. And obviously, every number from 0000 to 9999 must be split into either of these two camps. And because each even number has an opposite even number, each odd has an opposite odd, we can say that there are 10,000 over 2 odd numbers and 10,000 over 2 even numbers. If there are 10,000 of both. And we can say that even equals odd. Therefore, we can get like 5,000 odd numbers. Now notice how I said 0000 to 9999. Well, if this was a real AMC, that would screw people up. Hint, hint, clock blocked. But still, there's a way to compensate for stuff from 000 to 999 because we want to get rid of that. Now, we can just use intuition, but we can also use another way. Now, how do we get rid of these? We again apply the pairing technique. Pairing technique means if there's a number x with digits odd, then 999 minus x will also have the sum of. If this has odd digits, sum of digits odd, then this will have sum of digits even. This is odd, this is odd. And again, if x has the sum of digits even, then its pair number, 999 minus x, will have sum of digits odd. Therefore, if the total amount is 1,000, we can conclude that number of odds in here is 1,000 over 2, or 500. Subtracting this and subtracting this, we get 4,500 as our final answer.
All right, awesome. So now I'm going to be going over problem 21 with you guys.
So I guess we got some confusion about this. So I'm gonna try to go through this one more time just to see if I'm gonna try to explain it one more time. So Joey had a really good idea here. So what he said about this being even, and since the number, the sum of the digits in this number is even, if you subtract, pretty much what he's saying is if you subtract a number with the sum of the digits as odd, you will get another number that also has the sum of the digits as odd. So now what we want to notice here is that it says that how many positive 4-digit integers. So 4-digit integers go from 1,000 to 9999, which means there are 9,000 numbers like this. So pretty much, yeah. So now we just know that there are 9,000 numbers in all. Half of those are even and half of those are odd, which means 9,000 over 2, which is 4,500. So 4,500 of those are going to be odd, which means your answer is C. So yeah, the idea about 9999 minus some odd number or some even number, the summation of those digits being odd or even, that's a good idea, but then now this is just a quicker way to get to that 4,500 number that you're looking for. Okay, so now we're going to be going to Ian with number 21.
Awesome. All right.
Let's leave that up there for 5 more seconds, and make sure to ask any questions if you have any. So yeah.
All right, perfect. So if everybody's got this, I'm just going to erase it. So, so the next problem we're going to be working on is problem 21. It's a probability question that asks if there are knights in a line who are playing a game, and if and 2 knights compete, each with a 50% chance of winning, and they're lined up in a row with knight 1, knight 2, knight 3, knight 4, and our friend knight Jeffrey. And if 1 and 2 compete, and there's a 1/2 probability of winning this for each knight, and then the losing knight goes to the end, then what's the probability of Jeffrey winning the competition at least once in 20 rounds? So what we need to do in this problem is to figure out how many chances that Jeffrey has to win. Because once we figure out the number of chances he has, we can figure out his probability of winning. So what we do is we say, okay, how many rounds does it take for Jeffrey, who's right now in last, to get up to the front? In round 2, this is round 1. In round 2, he'll be here. In round 3, he's going to be here. In round 4, he's going to be competing. And if he wins round 4, that's great. But if he loses round 4, in round 5, he'll be back here. Now we have our sequence. It takes 4 rounds for Jeffrey to go up and get a chance at winning. So every four rounds, that's another 1/2 possibility that he might win. So we have 20 divided by 4, which is 5 chances of him winning. Now the probability of him losing all 5 of those rounds is 1/2 his chance of losing to the 5th, which is equal to 1 over 32. This is his chance of losing all 5. If we take 1 minus 1 over 32, this will give us his chance of winning, which is 31 over 32, which is your answer, A. All right. Now I'm going to hand it over to Min for problem 22.
Okay, so for number 22, first, like, you guys might have a hard time understanding the problem. So what it means that, let's draw a triangle, and the three medians, so basically the median is a line that connects to like the midpoint of each side length. So like that. And by the definition, this intersecting point is the centroid. And what that means is, by another definition of centroid, this length is always half of this length. And let's just label it B, C, D, E, F. So we're trying to construct a triangle using the three medians. Now, instead of finding the area of that triangle, we're first going to scale it down, meaning let's say we take this triangle side length, and this is 1/3 of this side length. And if we, for example, make a midpoint right there and connect it like this, this side length is 1/3, which is also 1/3 of this side length. So, and when you look carefully, this side length is also 1/3 of this side length, because this is half of this length because these two are midpoints. And since this is half of this one, these two are equal, have equal side length. Now, this triangle right here is a scaled down version of the triangle we're trying to find. And if you remember it, if we have a two similar triangle and have a side length ratio of A to B, the ratio of their area is A squared to B squared. In this case, the smaller triangle to bigger triangle, the side length ratio is 1 to 3. So the area ratio is going to be 1 to 9. And that means if we find the area of this triangle, we can just multiply it by 9 to get the area of the triangle that we want to find. And now, in order to find this area of this triangle, first, when you look at it, this triangle is 1/2 of this triangle because it has the same base and same height. And this entire triangle is also 1/2 of this triangle because this is the midpoint. That means the small triangle is 1/4 of this big triangle, which is 1/3 of the entire triangle. Meaning, this triangle we want to find is 1/12 of the area of ABC. And when you look at the problem, the three side lengths are provided, 17, 25, and 26. And so if we use the Heron's formula again, which is, we find the semi-perimeter, 17, 25, 26 over 2, which is 34. And that means the area of ABC is equal to square root of 34 minus 17, 34 minus 25, 9, 34 minus 26 is 8, which gets simplified into 17 times 4 times 3. So we would before multiplying these two, we're just gonna keep it there because what we're gonna do, we're gonna divide it by 12. So if this is the area of ABC, 17 times 12. If we divide this by 12, these two cancel out. So the area of this small triangle is 17. And the triangle that we actually want to find is 9 times this area. So 17 times 9 is 153, which I believe is B. And for those of you who can't click the Guru request button because it's hidden, if you zoom out the page like slowly, and then you will be able to access the button to request for Guru.
Thank you, Min. So okay, I'm just gonna put some labels here, just so it might be a little bit easier to understand. So what Min was saying, a median, the medians themselves cut themselves into 2-to-1 ratios. So pretty much this ratio is 2 to 1. So that's why I put 2B and B, and then he put the midpoint here. And then this 1 to 3 ratio that he had here, it's called a dilation factor. So the dilation factor of the side length can be squared to find the dilation factor of the area. So so he got this 1 to 9 when he squared the dilation factor. So and then he got, so that means pretty much what he did is go 9. He multiplied this 1/12 ratio to the entire triangle by 9 to get 9/12, which is 3/4 times the area of ABC. So yeah, but pretty much what Min said. So yeah, thanks, Min. I'll keep this up for 10-15 seconds. So just so you guys can put it in your brains. And also we'll be sending out a solutions PDF for the last 5 problems. So 21 through 25, there will be a solutions PDF going out to the newbies. So look out for that in your emails, because a lot of these problems are pretty difficult to understand and difficult to do on the real test as well. So yeah, I'll be going over number 23 now. Number 23, so let x and y be distinct positive integers such that x divides y, x plus 1 divides y plus 1, and x plus 2 divides y plus 2. Given that one of x, x plus 1, and x plus 2 is divisible by 7, what is the sum of the digits of the smallest possible value of y? Note x bar y means x divides y. So I'll just write that as a condition here. So x bar y means x divides y. Okay. So we're given in the first condition that x divides y. So since x divides y, x also divides y minus x. So, I mean, that's just given since x divides y and x divides x, so x divides y minus x. Also, you're given that x plus 1 divides y plus 1, which means that x plus 1 also divides y minus x. Also given that x plus 2 divides y plus 2, which means x plus 2 also divides y minus x. So I'll just just so this is kind of easier to understand, let's just say 2 divides 6, which means 2 divides 6 minus 2. So that's just like what we're doing here. Also, for these cases, it's like x plus 1 divides y plus 1. So instead of here where it's y minus x, it's x plus 1 divides y plus 1 minus x plus 1. And then here it's x plus 2 divides y plus 2 minus x plus 2. So yeah, now that's your condition. So that means x, x plus 1, and x plus 2 all divide y minus x. So now you're given that one of these is divisible by 7. And you're trying to find the smallest possible value of y, which means you're also trying to minimize, or yeah, you're just trying to find the smallest possible value of y. So that means you have 3 cases now for x. Triple of x, x plus 1, and x plus 2. You have 3 possible cases. So you can have it as 5, 6, 7, 6, 7, 8, and 7, 8, 9. So in all of these, one of x, x plus 1, and x plus 2 is divisible by 7. So now we're trying to find just the LCM of each of these as the value of y minus x. Okay, so the LCM of 5, 6, and 7, they don't share any common factors, so it should just be 210. The LCM of 6, 7, and 8, I'll just do it on the side. So it should be 84 times 2, which is 168. And then the LCM of 7, 8, and 9, they also don't share any common factors, which means it's just 56 times 9. Or yeah, I'll just do it out. Yeah. Okay. So now we can see that y minus x, the value for it, 168 is the smallest value for y minus x. So, and in this case, x equals 6. So x is 6 here. So I'll just move over here. So x equals 6, y minus x equals 168, which means y equals 174. For the other cases, you can just check if you want. So in the other case, x equals 5, y minus x is 210, and that means y equals 215. So, and then of course, for the other case, 504, it's also going to be bigger. So y equals 174 is going to be your smallest case for y, and it's asking for the sum of the digits, which means the sum of the digits is 1 plus 7 plus 4, which is 12. And for 12, the answer choice is going to be E. Okay. So, yeah. Good thing to know, just whenever you have these bar, like x divides y, you can subtract as many multiples of the left side as you want from the right side. So here we just subtracted 1 times each of the left side from the right side to get the same value. So yeah, I'll just leave this up for like 10 or 15 seconds so you guys can look over it and absorb it. And then we're going to be having Kevin do number 24 about Kevin. Yeah. Also, if you have any questions, make sure to ask the gurus. This is pretty, it's an inventive solution, but yeah. If you have any questions, make sure to ask and clear it up with the gurus while you can.
Okay, so this is number 24. Okay, so the question says Kevin randomly puts 3 yellow balls, 4 blue balls, and 6 green balls into 13 boxes ordered from 1 to 12, but it's supposed to be 13. There's a typo in the question, and then each box has exactly one ball inside, and Bob takes out the ball from box 1, then box 2, and then box 3, box 4, and then go on. And then so what's the possibility that the probability that all the blue balls are drawn before all of the green or yellow balls are drawn? Okay, so basically, because like we're drawing the green and or yellow balls before the blue balls, that means that the last ball must be green or yellow, and if it's green, then the last ball has a 6/13 chance of being green, and then if we take all these balls out, the last ball must be yellow, and that there's a 3/7 chance of doing that because there's six
But maybe you just mentioned when we go back on, just say there was.
Oh yeah,
an issue with the
Yeah, we're
battery.
still on. The mic is still on.
Wait, battery?
Yeah.
Is that?
Okay, so we had some difficulties with the battery. Now it's fixed. So getting back to this question. So after we take out the 6 balls, we have now after we take out all the other balls, we have 3/7 chance of picking the yellow ball, and then we multiply them together. So that gives so let's just write 3/7 times 6/13. So this is case 1, and for case number 2, the last ball is yellow, and there's 3/13 chance of the last ball being yellow because there's 3 yellow balls and 13 balls in total. And then we take all the yellow balls, and now we have 6/10 chance of the last ball, this like the remaining balls being green, and we multiply these two together, and we get 6/10 times 3/13. And now we basically have to add these fractions. So we would get 3/7 times 6/13 plus 6/10 times 3/13. And then we see there are a lot of common factors here, and we take out the 13th here, so it's 13. And then we can also take out a 6 and a 3, and then we would get 1/7 plus 1/10. And this would this would give us 153/455, and this would be B.
Yeah. So, okay, so pretty much the argument here is you want to have your blue balls to be all drawn before all the green or yellow balls are drawn. So which means you can never, if you have, let's say you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 spots. Also, there's a typo on here. It should just be 13 boxes ordered from 1 to 13. So yeah, it's not too big, but yeah. So you can never have your blue ball here, because that means you have all your greens and all your yellows drawn before that, because the blue ball is last. So what we're going through here is there are 3 yellows, 4 blues, and 6 greens. 4 blues and 6 greens. So that means since the blue can never be last, that means you're gonna have either yellow or green at the last spot. So this is your green case. So if the greens were last, that means you have a 6/13 possibility of it being in the last spot. And then now we're gonna be looking at all the yellow balls. So if you take out all of the green balls, that means you're taking out 6 balls from the 13. So take out all green balls. So now you're going to be left with 13 minus 6 equals 7 balls. So that means out of those 7 balls, now by the same argument, you want your yellow ball to be last. So you have 3 yellow balls, and the probability of the yellow ball being last is 3/7. So that's why here it's 3/7. So yeah, and then by the same argument, this is going to be your yellow case at the end. So at the start, the yellow is at the end with probability 3/13. Then you take out all of the yellow balls, and you're left with 10 balls. And then the probability of the green ball being last out of those 10 balls is 6/10. And then now you're just gonna go by the same process, and then you're gonna get 153/455 as the answer. Okay, so yeah, that was just, Kevin went over it, that was just another explanation kind of. So yeah, I'll leave this up for 10 more seconds, and then we'll just go over the last problem, number 25.
Question.
Yeah, also, yeah. Make sure to ask any questions that you have to the gurus. They're online waiting to answer any questions. And, yeah. Number 25. So Bob randomly picks an integer n from 65 to 127 inclusive. Consider the set 1, 2, 3, all the way to n. Bob randomly picks a subset of S. Bob writes all of the numbers in that subset in binary. He then lines them up so that all of the digits match up. Now he goes from right to left. If for any column there's an even number of ones, Bob writes the letter A. What is the probability Bob writes 6 A's? For example, he would write 110, 111, 001 for the subsets 1, 6, 7. He then would write 3 A's. So let's just go over like how this pretty much works. This is going to be like the example case. So 110. Actually, write it a little bit up more. So 110, and then 111, 001. So this is the subset 1, 6, 7. Yeah. So 1, 6, and 7. So now in this, here you have 2 1s, which means you have an A. You have 2 1s here, which means you have an A, and 2 1s here, which means you have an A. Okay, so that's just how like the problem's idea kind of works. So now you're gonna have, so now let's just get into like how the actual problem will work. So if you think of like the subset 1, 2, 4, 8, 16, all the way to 64, you're gonna have a subset like 0, 0, 3, 4, 5, 6, 1, and then 0, 0, 0, 0, 0, 1, 0, 1, 0, 0. I'm gonna try to make them line up. Okay. So now you're gonna have 1, 2, 4, 8, 16, 32, 64. So this is like an example subset that you would be taking. So in all of these, none of these are gonna have A because all of them have an odd number of A's. So any single number that you add here is gonna like kind of like toggle the A. So if you think of like the A being present or not as a switch, that's why we're gonna be calling it like toggling. So if we add like a number, just like, let's say we add the number 3. So that's gonna be 1, 1, and then zeros all throughout. So that means now you're gonna have 2 A's. So you're gonna be toggling the A now. So, and then these are all just gonna be non-toggling. So every single one you add to each of the 7 columns, you're gonna be changing an A to an A, or changing an A to a not A, or changing a not A to an A. So that's why we're thinking of it as a switch. So that means in each of the 7 columns, you're gonna have 2 possibilities. 3, 4, 5, 6, 7. So, yeah. That means in all you have 2 to the 7, which is 128 possibilities. Okay. And then now you want 6 A's to be present, right? Yeah. So what's the probability that Bob writes 6 A's? So out of these 1, 2, 3, 4, 5, 6, 7, you want 6 A's to be present. So you're just trying to choose which of these, out of these 7 spots, which 6 will have A's. So it's just going to be 7, choose 6, which is 7. And that means the probability is possibilities that work over total possibilities, which is 7 over 128, which is answer choice B. Yeah. So that was a pretty difficult question. So also just ask our gurus if you have any questions. They'll get right to you. And yeah, I'll leave this up for like 15 seconds. And yeah, we'll also just remember that we're going to be sending out like full solutions to 21 through 25. So if these were like pretty hard for you, it's okay. It's like they're supposed to be hard questions. So don't be like discouraged. And AMC is coming up, so make sure to study. And now we're gonna have Hannah.
Oh, yeah. Okay. So, hi guys. We all just wanted to thank you for coming on live today with us. We had a lot of fun, and we hope you did too. Just a brief side note: we will be releasing shortly after this live ends. We will be releasing mock exam number 2. In which the office hours for mock exam number 2, which is different from the mock exam number 1, will be the same time next week on, next Saturday, from, 1 to 3 p.m. So we hope to see you next Saturday. If you have any questions or concerns, please email info@peergenius.com. Thank you so much. Bye.